everyone, I'm Mauricio Velasco, and in this video, I'll go over the first demo of the adversary simulation tool that I'm presenting at Black Hat Arsenal 2020 called PurpleSharp. In this first demo, I will use PurpleSharp to simulate two tactics of the attack MITRE framework: execution and persistence. As part of the attack lifecycle in an intrusion, adversaries will most likely engage in these two tactics to achieve their goal. I picked these techniques as they're commonly used by adversaries. If you want to learn more about this, you can go to the Attack Mitre's website, and where they list out all the reports, open source reports, they have found where threat actors and malware authors are using this technique across cyber espionage and cybercrime. The techniques are PowerShell, Visual Basics, Schedule Task for execution, and for persistence, we're going to use Windows Service and WMI event subscription. Um, okay. Before I start the demo, I'd like to start with a question. Like, if you are a blue teamer and your team is monitoring their environment, we know that these are common techniques used by adversaries. So the question is, how do you know, how can you confirm if your team, if your SOC, if your MSS P is detecting these techniques? One way of doing this is through adversary simulation, and today I'm going to do it with PurpleSharp. Before I jump to the demo, I just want to quickly describe the lab environment that we're going to be executing the simulations. We have a domain environment, a Windows domain environment with a few hosts, and in this domain environment, we have configured Windows event subscription. And all these logs are being sent to Splunk, so we're getting Windows event logs and Sysmon events. The simulations will be executed from an endpoint that is not part of the domain. Okay. All right. So we'll jump to our lab environment. So we have here our operator computer that has PurpleSharp, and we have Ubuntu and a few other Windows boxes. Okay. So for the first demo, we'll execute a PowerShell technique. I'm not going to describe the parameters or how PurpleSharp works. So please go refer to the documentation to understand that. So in this case, I'm going to execute a technique against Windows 10-1, so this host. I'm going to use the user P#. Remember that this user needs to be a local admin on this endpoint. This is the password for the user, the domain, and finally the technique. So PurpleSharp will upload the scout to this path because since we didn't define one, it's going to use the default one. It's going to execute the scout and connect to it via name pipes. The scout will retrieve some recon. In this case, it identifies that the user M Simpson is logged into this host as as you can see here, March Simpson. Based on that, PurpleSharp will upload the simulator in a path within this user's profile. In this case, the downloads folder. Then PurpleSharp will pick a process to use for the simulation. In this case, we're using the parent process ID spoofing technique so that our simulation looks credible, and it's going to be a child process of Explorer. This is what you get back when you run the tool. First, we have a header where it states the technique that we're using against the host it's running from. We also get the path where the technique is running from, the process ID, and then the context of the simulator the simulator is running under. In this case, it's March Simpson. So as you can see, PurpleSharp is running the simulation under the context of the user who's logged in here on this host. Okay, so we see some logs for this particular technique. In this case, it's going to execute this particular command with this encoded PowerShell command. It starts this process ID and it finishes. As you can see, I also added here detailed timestamps so we can correlate that with our logs. Finally, PurpleSharp cleans up after itself. So if we go to our logs here, we can see that we're getting events from our endpoints on our Splunk environment, and in this case I'm going to look for logs in the past 5 minutes from this particular host. Oh, wrong one. And as you can see here, I'm going to sort by time. As you can see here, we see a 358 scout running and the scout runs under on from this path, and actually runs under the context of P sharp, which is what I'm going to call the service account that I'm using to deploy the simulations. And after that, you see the simulator running, which is running from a path within the user profile, right? In this case, the downloads folder of Marge Simpson, and it's running under the context of Marge Simpson. So once again, this is one of the benefits of PurpleSharp, being able to deploy simulations that run in the context of actual users, so we can create credible simulations and train our SOC, or test our detection. As you can see, we see PowerShell running with this encoded command. Okay, so the question at this point is, do you have the visibility to detect this attack? Did you get an alert when someone executed this? Well, PurpleSharp can easily allow you to do that. One important thing as I was building PurpleSharp for me was the ability to execute different techniques. And PurpleSharp will actually execute the PowerShell technique in two different ways. One of them is going to be just use the Windows 32 API called create process just to execute PowerShell. But then another way of doing it is executing PowerShell encoded command using .NET and using PowerShell.create and invoking it. So this is going to look different on the logs. So you may be able to detect one way of the PowerShell technique, but maybe not this one. And PurpleSharp will allow you to test both. Okay. Okay, so we're going to move on to run the next simulation. In this case, we are going to run this with PurpleSharp. Let me explain this real quick. So we're adding a couple of parameters. First, we're going to execute the Visual Basic and the schedule task techniques together. We're defining the path for the scout. In this case, we're gonna make it look like as if it's PSExec. We're defining also the path of the simulator to make it look like as if someone downloaded iTunes. And we're gonna add this pbsleep parameter, which defines that it's gonna execute these two techniques in a chain, but it's gonna wait 15 seconds between one and the other. Okay. As you can see, we're running it against a different host, this time Windows 10-3. And in this, we see that the scout is being uploaded to a different path. We see that in this case, we find the user H. Simpson logged in. And PurpleSharp would then upload the simulator to the download folder and the iTunes file as we define. And it's going to once again execute the technique using parent process ID spoofing. So we'll wait a few seconds for it to finish. So it does finish, and now we see the results. So as we can see, it first executed the first technique, Visual Basic, by running this command, and then exactly 15 seconds later at 4:04:28 seconds, it starts the second technique. In this case, it's going to execute create a malicious schedule task with this command line. We once again get the process ID, where it's running from, under which context. So we'll go back to Splunk and see those logs and see how that looks like. Okay. And we'll update here the name of the host, which is Windows -3. And as we can see, if we sort out, as we can see once again, we see the scout running from this path under the context of the service account P#. Then we see iTunes running. Then we see this execution of this what looks to be a potentially malicious BBS script. At 4:04:13, and 15 seconds later, the schedule task is created and then deleted, as you can see. So PurpleSharp will clean after itself. So once again, the question I will ask you is, can you detect these techniques? Well, the only way of knowing is by testing them, and you can do it with PurpleSharp. So moving on to the demo, now I'm going to execute a different technique. In this case, I'm going to create a malicious service with PurpleSharp. Okay, so we're going to run that. We're just going to use the default Scout and simulator path, and it's going to run against Windows 10-2 now. Now, because this technique requires a high integrity process, the Scout will actually pick a process in high integrity to run this technique. In this case, winlogon.exe. Otherwise, we will not be able to create the service. In this case, we create the service with the command line using the sc commands, as you can see here. And it is run at 40717, right? And then it deleted itself. So if we go to Splunk and we look for events of a service being created, you can find here the event that happened at 40717, as we saw on PurpleSharp logs, where this service, updater service, running from this weird path, was installed on Windows 10-2, right? So once again, really easy way of simulating an attack with PurpleSharp. Okay. And following the design of trying to execute the same technique in different ways, PurpleSharp supports two ways of executing this technique. One is the one we just executed using the command line and just the sc create command. But as you can see on this other one, it also supports creating a service using the Windows 32 API create service function. So first it's going to use OpenSC Manager and then create service. So maybe you can detect it in one way, but maybe not the other. So you can use PurpleSharp to confirm that. Okay. Okay. And then finally, we're going to execute one last simulation. This case, we're going to create a malicious WMI subscription. And I'm going to add an extra parameter here, no cleanup. So by default, PurpleSharp will clean after itself. So if it creates a service, if it creates a scheduled task, if it creates a user, it will delete them. But with this parameter, we're going to leave them so we can confirm that the WMI subscription was created. Okay, so we're going to run this against Windows 10-2. It's going to follow the process again. It's going to pick a high integrity process because this technique requires high integrity. And as you can see, I'm going to log in. Okay, so as you can see on the logs, it created a malicious WMI subscription using system management .NET namespace. It created a command line event consumer. It created the filter to consumer binding. And because we add the no cleanup parameter, it's not going to delete it from that host. So we leave it there. So if we go to that host and we go to PowerShell and look for that, we can see that this event subscription was actually just created. And in this case, it's gonna just execute PowerShell. This is a common way for attackers to obtain persistence, and the code will actually run a system. We just able to simulate a malicious WMI subscription with PurpleSharp. So this ends demo number 1. I'll see you on the next one.